Just take a deep breath, a really, really deep breath. That's probably the thing that we take most for granted as human beings. Well, that breath you just took, the gases you consumed into your lungs at that moment, the oxygen that your lungs and your blood vessels were filled with, that oxygen is something that was not created by planet Earth itself. It was actually created by biological activity. What happened is that the early Earth had no oxygen. It was a very hot place, very acidic place. It had very different kinds of landscapes. Nothing in terms of multicellular organisms had evolved yet. It was a pretty difficult place to be, unless, of course, you were one of the early anaerobic, non-oxygenated microbes that liked to live in an environment with no oxygen. So we had bacteria and archaea, a few eukarya, but not a lot of other things. And in that early Earth, oxygen was actually very toxic. In the modern day planet, all of us know that you can smell hydrogen sulfide, that smell of rotting eggs, very clearly. And in fact, our noses, our olfactory system, has been designed and evolutionary crafted to be able to give us an early warning system of toxic gases like sulfide. But in the early Earth, there was a lot of sulfide and there was no oxygen. And in fact, then the oxygen on the early Earth was the gas that was very toxic. Well, as organisms began to evolve, and especially the bacteria, they were able to develop a geochemical, biochemical pathway that allowed them to combine things like CO2 and sunlight to produce sugars they needed for their cells, as well as oxygen. And so that was called photosynthesis. And photosynthesis was a process that was evolved not by plants, but by bacteria. So the earliest bacteria came on the Earth, 3.9 billion, 3.8 billion. We know for sure that there were microorganisms fossilized by about 3.7 billion years. So in that kind of time frame, we had the very early onset of these microbes living on planet Earth in an environment that had a lot of toxic gases to us, which are not toxic to them. And there was almost no oxygen. Then they evolved the physical, biological process of photosynthesis. And that photosynthesis was first developed by bacteria in environments with no oxygen. Well, the photosynthetic reactions and the organisms that do those became so prevalent, so efficient, so widely distributed that photosynthesis was going on every place around planet Earth, and the oxygen that was produced by that photosynthetic activity flooded the atmosphere and flooded the oceans with oxygen. And it flooded them to an extent then that that oxygen built up, and by 2.5 billion years before present, which is the boundary between the Archean and the Proterozoic time periods in the Precambrian, the Earth had become oxygenated. So what was originally a very scarce and low abundance gas became one of the dominant gases that prescribed the environments in which all future organisms were going to evolve. So photosynthesis itself was evolved by microorganisms, by bacteria. And eventually through time, that process was transferred over to the eukarya, the multi-celled eukarya that are algae and plants. And that process itself, a biological revolution took place, flooded our planet with oxygen, and made it the oxygenated Earth that we are accustomed to and take so for granted. You can almost not imagine another process on planet Earth which can be driven by biology that can so fundamentally change everything that happens from that time point forward. So even oxygen itself is a biological product on planet Earth. And once that oxygenation kicked in, then all other evolutionary biology was fine-tuned to these environments that were dominated by oxygen. So next time you take a deep breath, don't take that oxygen for granted. Those oxygen molecules were produced as a result of photosynthetic activity of originally bacteria and now plants, which are flooding continually the atmosphere and the oceans with oxygen. And that event of biologically driven oxygenation of the atmosphere, which reached very high levels by about 2.5 billion years before present, is fundamentally the benchmark event that set the stage for all the ensuing evolutionary biology that we've seen take place during the Proterozoic and then throughout the Phanerozoic.